Imagine you build, just a simple weekend project to play some MP3s.
Right, like a basic local media player.
Exactly,
Yeah.
just managing a few video files. And you feed the code to an artificial intelligence, maybe expecting a quick pat on the back.
Or just some minor code optimization. Right.
Yeah, exactly. But instead, the AI flags your code. It literally stops its standard processing.
Oh, wow.
And it essentially tells you, you haven't built a jukebox, you've built a sovereign media operating system.
Which is just a massive leap from a weekend project.
It really is. And that is exactly what happened to the architect we're studying today. Welcome to the deep dive, by the way.
Thanks. I'm excited for this one. We're looking at a diagnostic landscape that is entirely murky.
Super murky.
Yeah, the lines between a simple media player and a localized data empire are just completely blurred here.
It's the definition of diagnostic muddy waters.
Oh, absolutely. And I mean, the most compelling part isn't just that the AI recognized it. It's the fact that the human architect, this developer named Bruce, he had to build an intricate defensive web of documentation.
Just to stop the AI from accidentally destroying the masterpiece it had just praised.
Exactly. It's wild.
It is wild. And, we have the actual source materials for all of this. Our mission for this deep dive is to explore this entire stack of documents.
And it's a dense stack.
It's very dense.
Yeah.
We have the architectural design files, which are labeled the ironclad architecture.
Such a cool name.
Right. And we have the literal chat transcripts between Bruce and the AI, which I have to say are wildly entertaining.
They really are. It reads like a sci-fi script sometimes.
It really does. And most importantly, we have a massive framework of JSON files.
Yes. The memory brain.
Yes, the literal memory brain for this entire localized media OS, which he calls MusicPortal.
So we're going to unpack how this sovereign algorithm-defying ecosystem actually functions today.
Exactly. But I think we should establish the stakes early on, too, because this isn't just a look at some nostalgic, retro MP3 player.
No, definitely not. We are really dissecting the philosophy of data ownership here.
Which is a huge topic right now.
It is. We're exploring deterministic reconstruction, which is a fairly heavy infrastructure as code principle.
But applied to personal media, right?
Right. And we're going to look at the mechanisms of how a human actually taught a language model to understand the blast radius of its own code suggestions.
The blast radius. I love that term.
It's so accurate, though, because this is fundamentally about software survival, especially in an era where cloud platforms just completely dictate what you can and cannot consume.
Yeah. So to you listening right now, how much of the digital media in your life do you actually own?
Really think about it.
Right? Like not rent. Not streamed from a cloud algorithm that can just pull a song or an album at midnight because, I don't know, a licensing deal expired.
Which happens all the time.
All the time. What do you physically hold on your own hardware? Because what Bruce engineered with MusicPortal is a total rebellion against the renting economy.
It's a complete paradigm shift.
Yeah. So to really understand the technical weight of this, I want to start by recreating that exact chat transcript where the AI realizes what it's looking at.
Oh, this is the best part.
Right. So I'm looking at Bruce's initial prompt, and he is playing it incredibly cool.
Oh, totally downplaying it.
Yeah. From his perspective, he writes, at quick glance, my project seems like it's not dope, nothing fancy.
Nothing fancy.
Right. He calls it a curation studio and a jukebox live. He even says, I leave my DVD file sitting right on a local server, and my jukebox knows no different.
He's literally pitching it as just a highly basic script.
But the AI is not buying it.
Not at all. You can almost track the parsing logic of the AI as it ingests the repository. It flat out rejects his humility.
It really pushes back.
Yeah, it says, that's a fair read of it on the surface, but once you step into the behavior layer, it's closer to a local orchestration system with multiple control planes.
It's basically like, nice try, Bruce.
Exactly. It looks at this supposed pet project and formally categorizes it. It calls it a media virtualization layer.
And a personal media OS.
Right. The AI identified 4 distinct hidden layers that just completely mask all the complexity from the user interface.
I really want to bring those layers down, actually, because the way the AI dissects them is fascinating.
Yeah, let's do it.
It starts with what it calls the curation brain. Now, if I'm reading this right, this isn't just a basic CRUDAP, right?
Right, not just create, read, update, delete.
Yeah, for playlist management, it actually operates the studio part of the portal. It acts as a human-in-the-loop decision layer.
Handling all the metadata tagging, the rating systems, the deep filtering logic.
So it's basically the governance layer deciding what fundamentally deserves to exist in this local universe.
Correct. It establishes the persistent state of user preference, and then directly beneath that governance layer, the AI found the execution engine.
The Jukebox Live.
Exactly.
Yeah.
And the AI noted this is a robust playback state machine. It handles the real-time switching between embedded YouTube iframes and local audio.
Wow.
Yeah, and it actively enforces timestamp slicing and seek offsets.
Which actually brings us to the third layer, right? The media virtualization layer.
Yeah, this is the one.
This is where my eyebrows really went up. Bruce mentions this thing called a concert slicer.
The concert slicer, yeah.
Because I know from my own tinkering, if you have a massive 10 gigabyte MKV file, like a fully ripped DVD of a live concert.
Oh, that's a nightmare to manage.
It really is. Most media managers force you to extract the audio track, chop it up in an audio editor into individual MP3s, and store those separately.
Which is just a highly destructive, time-consuming process.
Yes. But Bruce isn't doing that at all here.
No, he's taking an entirely non-destructive approach. He actually leaves the massive 10-gigabyte immutable media container perfectly intact on the drive.
Just sitting there.
Just sitting there. The concert slicer parses that enormous file on the fly. It treats the single container as a logical playlist by using time-based virtual tracks.
So the AI realized this is conceptually identical to how enterprise database views operate over raw SQL tables.
Or how a virtual file system mounts a drive. It's behavioral virtualization.
Okay, wait, so let me get this straight. The system says track 4 starts at 45 minutes and 12 seconds and ends at 49 minutes. But track 4 doesn't actually exist as a standalone file.
Precisely. It's just a set of coordinates pointed at the master DVD file.
That is incredibly efficient.
It's brilliant. And the final layer coordinating all of this is the system control plane.
Okay, what's in there?
This contains the localized API hooks, the operating system level file purging, blacklisting protocols, watchdogs.
So the user interface is literally just a thin HTML shell orchestrating this massive stateful back-end infrastructure.
Exactly. The UI is just the tip of the iceberg.
Okay, well, let me play devil's advocate for a second.
Go for it.
If this architecture is so incredibly well designed and the AI is practically writing a love letter to the code base,
It really was.
then why does the transcript show Bruce complaining to the AI about how much heartburn previous models caused him?
Ah, yes, the heartburn.
He gets highly defensive later in the chat. He says, I do not let Flash models touch my curation studio, my Jukebox Live. Never again. They won't touch it. It was too painful.
He was very adamant about that.
Yeah. So if AI is perfectly capable of reading the architecture, why did it chronically break his system in the past? Did it just write syntactically bad Python or something?
It actually wasn't writing syntactically bad code. It was writing operationally catastrophic code.
Operationally catastrophic. What does that mean?
Well, the AI in the chat actually diagnoses the problem perfectly. It explains the concept of state integrity boundaries.
Okay.
You have to understand how fast reasoning AI models work, what Bruce calls flash models.
Right.
They don't have a persistent physiological fear of failure.
Like they don't get paged at 3 a.m. when a production database drops.
Exactly. They don't feel the consequences of a bad deployment.
They just generate text.
Right. They lack the context of operational risk. So when a standard Flash LLM looks at a block of code, its primary directive is usually optimization.
It wants to make it look cleaner.
Yes. It looks for efficiencies, shorter loops, cleaner syntax. It will happily suggest refactoring a 50-line Python ingestion script into 10 lines of elegant code.
Cool. What's the catch?
The catch is it doesn't realize that in doing so, it just bypassed a hidden file lock. Or it ignored a playback state coupling that relies on specific timing delays.
Oh, because the AI just sees text on a screen. It doesn't see the running machine processing a gigabyte of data in real time.
Right. It views code as a static logic puzzle, not a physical mechanism with momentum.
That makes so much sense.
Yeah, so the AI in the chat assesses that Bruce's caution isn't just a developer being overly protective of his code.
It's not just ego.
Exactly. It is correct operational containment. Bruce built a system filled with destructive flows, purging unwanted media, permanently blacklisting files, modifying the master vault.
These are non-idempotent actions. Like, you can't just undo them easily.
Right. If you run a destructive script twice because an AI removed a safety check, you don't just get an error message, you get permanent data loss.
And Flash models trample all over these sacred state zones because they just lack the contextual memory of the system's physical vulnerabilities.
Yeah, exactly. They don't know what's physically at risk.
So Bruce didn't just build a clever script. He basically built a bunker.
A digital bunker.
He engineered an architecture based on strict survival principles, defending against external threats.
And those threats aren't just bad AI refactors, you know.
No, they're failing physical hard drives, dropping internet connections, cloud platforms, altering their APIs without warning.
Which transitions us perfectly into the documentation for the ironclad architecture.
And what Bruce calls taking back the data. I love that.
It's a great manifesto. To really grasp why he cares so much about state integrity, you have to look at how this physically lives in the real world. He operates what he calls a tri-drive empire.
Tri-drive. Okay, so 3 drives.
Yes. The modularity of the storage is totally key to the survival aspect. Drive C is the solid-state drive dedicated purely to the system and logic. Right. Drive D is the active intake. That's a high-speed drive for rapidly processing MP3 slices and temporary files.
Okay, the workbench.
Exactly. And Drive E is the sovereign film archive. That's a massive external vault holding those multi-gigabyte immutable DVD masters we discussed earlier.
Wow. So to see this in action, the documents actually outline these incredibly vivid real-world deployments. Like, he's got this entire backend running in a 2011 Ford F-150 EcoBoost.
Which is just so cool to picture.
It is. Imagine you are driving out of the city, heading totally off-grid. The cell service drops from 3 bars to 1, and then just to nothing.
A classic road trip scenario.
Right. If you rely on a standard streaming service, your app either buffers endlessly into silence, or it traps you in a local cache loop of the same dozen songs.
You're completely at the mercy of the cell tower.
Exactly. It exposes the absolute fragility of an ecosystem reliant on corporate servers that you have no control over.
But inside the truck, MusicPortal is completely indifferent to the cell tower.
It doesn't even know the internet exists.
Right. The entire jukebox is running on a localized Python server, physically housed in the truck, feeding offline, uncompressed MP3s right off that intake drive.
The documentation mentions him blasting a hand-curated playlist of Japanese female-fronted heavy metal bands.
Like band-made Love Bites, Hagain.
Yes. 0 bandwidth required. No ads, no telemetry data being sent back to a corporate headquarters. It is pure audio sovereignty.
And then, we look at what happens when the off-grid mobile experience transitions back to the home base.
The system scales up dramatically for the living room, right?
Yeah, into what the architecture calls the 70-inch command center.
Which presents a completely different UI challenge. I mean, standard desktop media players look absolutely ridiculous if you cast them to a massive 70-inch television.
Oh, yeah. The typography is unreadable. The margins are awkward.
And you have desktop taskbars ruining the immersion. It's terrible.
So Bruce engineered a custom stealth dark UI geometry. The documentation specifies that the video theater expands to exactly 54% scale.
Very precise.
Very. While the control deck anchors perfectly at the bottom, entirely dodging the Windows OS elements.
But the visual layout is secondary to the actual engineering marvel running beneath it, isn't it?
Oh, definitely. The dual engine logic.
Okay, explain the dual engine logic.
Well, when Bruce queues up a session, for example, a high-speed guitar solo video from a guitarist named Mew Chan,
Okay.
the system is doing something deeply complex. It is actively syncing a muted, ad-free 4K YouTube video playing inside a hidden browser iframe.
Wait, muted?
Yes, muted. And it's syncing it with a pristine, uncompressed local audio file streaming directly from his hard drive.
Wow. I'm really trying to wrap my head around the mechanics of that. If he's playing local audio through a Python backend, and the video's playing in a completely isolated web browser iframe,
Yeah.
how does a local script force a browser to stay in sync?
That is the big question.
Are we talking about WebSockets pulling the DOM? Because, I mean, if the browser buffers that 4K video for even 100 milliseconds, the audio drift would be agonizing to listen to.
It would be unwatchable. You've hit on the exact technical friction point here. Standard embedded media players drift easily because they operate in separate execution threads with no master clock.
So how did he fix it?
Bruce solved this using what he terms hard-state logic. The local Python backend acts as the absolute dictator of time.
The dictator of time.
Literally, it continuously polls the playback state. If it detects that the browser iframe has desynced from the local audio file due to a dropped frame or a microbuffer, the backend physically overrides the browser API.
No way.
Yes, it forces the video player to seek to the exact millisecond of the local audio track, slamming them back into perfect lockstep.
So it doesn't ask the browser to catch up. It dictates the time coordinates via local socket commands.
Precisely. It dictates terms to the web rather than the web dictating terms to the local machine.
That is brilliant. And this theme of bypassing standard web restrictions, it shows up again when we look at how he shares this media.
The zero-dependency curated gift.
Yes. Let's say he curates the perfect 5-star playlist and wants to give it to his wife, Joyce. Usually sharing a playlist means, texting a Spotify link.
Which forces the recipient to have an account, download an app.
And probably listen to unskippable ads. It's a terrible user experience disguised as convenience.
It's the total commodification of the sharing experience.
Exactly. So Bruce clicks an orange gift tag in his custom UI and hits export gift JSON.
And then what happens?
His backend Python script instantly processes this and generates a single standalone HTML file. He drops this one file onto Joyce's Windows 11 laptop.
Just one file.
Just one. When she double-clicks it, it opens a fully functional, custom-built playlist launcher right in her local browser. She doesn't need a Python server running, and there is no database required on her end.
That's incredibly clean.
It is. But here's my question. How does that actually work with modern browser security? Right. YouTube has aggressive DRM and copyright bots. Browsers have strict cross-origin resource sharing, or CORS. Policies specifically designed to block a local HTML file from executing complex scripts or accessing local media directories alongside embedded web players.
You're entirely right. By default, a modern web browser will throw a severe CORS error and completely block the execution.
So how does he get around it?
To bypass this, Bruce utilizes a technique the documentation calls a ghost origin injection.
Ghost origin sounds stealthy.
It is. Essentially, he is dynamically rewriting the headers and the origin state of the local HTML file as it executes, tricking the browser's security model.
So the browser is manipulated to believing this local file isn't just a raw file sitting on a desktop.
Exactly. It thinks it's a secure file being served from a legitimate origin. This completely drops the cross-origin blocks, allowing the local media to play flawlessly alongside the embedded, ad-free video logic.
It creates a completely self-contained digital gift box that circumvents web security without compromising the host machine.
That is some serious defensive engineering right there.
It really is. Which leads us to the final and perhaps most philosophically important scenario, the immortal data vault.
This is the ideological core of the whole architecture.
Because we all know that platforms like Apple Music track every millisecond of our listening habits. They know when you skip a song, what you loop, what you listen to at 2 a.m.
And they hoard that telemetry data to feed their own algorithms and optimize their ad revenue.
But MusicPortal flips that dynamic. It tracks your data exclusively for you.
Right. As you are watching that 70-inch display, the backend API is silently monitoring the playback state.
Okay.
The exact millisecond a song crosses the 30-second playback threshold, a localized Python listener intercepts the signal. It reaches directly into the hard drive and surgically updates a master ledger called goldvault.json.
So it's logging your personal play counts, your 5-star rankings, your custom emotional tags, and it writes them permanently into a simple, universal text file that you completely control.
Yes, it's a living, breathing ledger of your musical life.
If Spotify goes bankrupt tomorrow, or if a label pulls an artist's entire discography, your data, your history, your preferences survive completely intact.
It guarantees data immortality, but, if we step back and look at this as data architects, an immediate logistical nightmare presents itself.
Well,
This isolated, beautifully sovereign ecosystem sounds incredible, but how do you actually populate it?
yeah.
If you have to spend your weekends manually typing in metadata, artist names, track titles, release years, genres, custom tags for tens of thousands of songs.
The system ceases to be an entertainment portal.
Exactly. It becomes a massive data entry burden.
Yeah, nobody wants to clock in for a shift doing database management for a hobby project. If the friction of adding new music is too high, the whole system dies.
Exactly. And that friction is what necessitates the concept of deterministic rebuildability and the truck workflow.
The truck workflow, the AI in the chat immediately identified this as a highly sophisticated reinforcement loop, right?
It did. The premise of the sovereign jukebox is staggering. Bruce actually challenges the AI with a hypothetical.
I remember this.
He says, imagine he loses his entire physical system. His hard drives fry, his computer melts, the house burns down, everything physical is gone.
Total catastrophe.
The only thing he has left is one small thumb drive in his pocket that holds his project source code and that one text file, the goldvault.json.
Okay.
He plugged that thumb drive into a brand new factory reset computer. He runs the install script, hits a single button, and walks away.
And the system completely rebuilds itself from scratch.
Yes, it reaches out to the internet, fetches tens of thousands of songs and videos, recurates them, rebuilds the MP3 slices, repopulates the databases, as if the catastrophic failure never happened.
When the AI analyzed that workflow, it recognized a specific enterprise-grade architectural pattern, didn't it?
It noted that everything in Bruce's system, except for the raw multi-gigabyte DVD storage, is treated as entirely ephemeral.
So it's fully reconstructible from a single source of truth.
He is borrowing heavy concepts from Git version control and modern infrastructure as code deployments.
It's the difference between backing up your files and backing up the instructions to recreate your files.
Precisely. If you use standard software like iTunes, the media file itself is the state. If you lose the file, you lose the music.
But in Bruce's system, the goldvault.json is the state.
Yes. The media files are just temporary physical manifestations of that state.
That is mind-blowing. So let's look at how he actually interacts with this pipeline on a daily basis. Let's walk through the truck workflow, which is the human-in-the-loop mechanism that feeds this system.
Step 1 is discovery.
Right. Bruce is driving the F-150 down the highway, and he's listening to a temporary, uncurated playlist.
He hasn't downloaded these forever. He's just passively consuming a stream of new music.
Okay, then what?
Step 2 is the signal. He hears a track that resonates with him, but he doesn't pull the truck over to type metadata into his phone.
That would be way too much friction.
Exactly. He reaches over and physically taps a large button mounted on his dashboard.
Just a big physical button?
Yep. That single zero-friction action fires off a signal that simply tags the current playing song on a lightweight Google Drive list. It captures pure human intent without demanding manual labor.
Then we hit step 3. Materialization. The drive ends. He walks into his house, sits at the command center, and hits one button on the UI.
And the magic happens.
The system begins a massive batch reconciliation process. It reaches out, fetches the timestamp tags from the cloud, cross-references them, pulls down the high-quality source files, curates the metadata, rebuilds the MP3 slices to his exact specifications.
And here is the crucial part.
Yeah.
It takes all the tracks from that temporary playlist that he didn't tap the button for, and it throws them into a permanent discard or blacklist protocol.
Which seamlessly triggers step 4, governance. Future automated playlists dynamically inherit these new rules.
The blacklisted tracks are permanently banned from ever being downloaded or played again. The freshly tagged tracks are entered into the heavy rotation algorithms.
What's fascinating here is that the AI explicitly categorized this not as a simple library management tool, but as a feedback-driven media compiler with a persistent preference memory layer.
A feedback-driven media compiler. It has a full content lifecycle. Stream for discovery, signal your preference with zero friction, deterministically rebuild the asset for permanence, and enforce future governance.
It's an incredibly elegant data pipeline. But, here is where my skepticism kicks in. And I think anyone listening who has ever tried to chain scripts together is feeling the exact same anxiety.
The fragility of the automation chain.
Yes. If the entire ecosystem relies on a single JSON file to rebuild itself, and it relies on all these discrete automated steps, how does it manage the sheer complexity of the moving parts?
It's a lot of plate spinning.
Exactly. You have batch scripts talking to Python listeners, HTML portals making API calls, and external C++ media players like MPV and VLC executing commands.
Right.
If you accidentally delete one line of a Python script, or if an overly eager AI tries to optimize a batch file, doesn't the entire Rube Goldberg machine collapse? The blast radius of a single typo must be astronomical.
You have identified the exact vulnerability that kept Bruce awake at night. The system has incredibly heavy cross-layer dependencies.
A minor UI tweak in the HTML front end can inadvertently alter a variable that a Python file operation requires, right?
Exactly. Which subsequently causes a batch script to fail, leaving an external C++ media player frozen in the background consuming memory.
And that exact terrifying fragility is why Bruce was forced to engineer the most complex and fascinating part of this entire deep dive.
The memory brain.
The memory brain. This is where we really need to dive deep into the technical mechanics of AI interaction.
We really do, because large language models have limited context windows. If you just paste 5,000 lines of disparate code into a chat window and say, fix this, the LLM loses the forest for the trees.
It will hallucinate functions.
Yes, or it will optimize a single script while remaining completely blind to the fact that the script feeds a vital downstream process.
So to stop the AI from hallucinating or accidentally destroying his delicate architecture, Bruce mapped his entire ecosystem into a dense web of interconnected JSON files.
He literally built a deterministic RAG retrieval augmented generation pipeline out of JSON.
He created a mapped brain that explicitly teaches the AI exactly what it is looking at, piece by precise piece.
It's astounding. He built a map for the machine, specifically so the machine wouldn't break the map while trying to read it.
Let's really unpack the anatomy of this application, because these JSON files are a masterclass in AI wrangling. Let's start with portalawareness.json and file role registry.json. Why does an AI need a file just to tell it what an HTML portal does?
Well, let's look at portalawareness.json. The AI needs to understand the physical constraints of the UI layer. This file registers all 15 custom HTML portals Bruce constructed.
It lists endpoints like portalcurationstudio.html and portalmatrixbuilder.html.
But crucially, it doesn't just list their names. It defines their physical capabilities.
Like what?
It explicitly tells the AI which portals possess has-fetch capabilities for making external API calls, which portals have has audio tags, and which rely on a has YouTube bed.
Oh, I see. So if the AI knows a specific portal lacks has-fetch, it won't hallucinate a solution that requires that portal to suddenly start querying a database.
Exactly. It knows the physical limitations of the screen it's analyzing. It establishes semantic boundaries.
And then fileRoleRegistry.json performs a similar mapping for the back-end Python scripts, right?
Yeah. The AI is explicitly taught the organizational chart of the software. It learns that core/API listener.py acts exclusively as the app gateway.
It is taught that core/scrub.py is the data cleaner.
And that scripts like vaultingester.py are explicitly Vault components.
It's literally an HR directory for robots. If the AI is tasked with fixing a data parsing error, it knows to go talk to the data cleaner guy, scrub.py.
It won't attempt to force the API listener to handle the scrubbing logic, which would just convolute the codebase. It respects the division of labor.
But knowing who's responsible for a task isn't enough to prevent catastrophic failure, right?
No, the AI needs to deeply understand how the execution flows through time and memory. That brings us to subsection B of the brain, mapping the execution.
Okay, what files are in this section?
This involves dependencygraph.json, runtimemap.json, fieldmap.json, and the orchestration maps.
Let's break those down, because this is where the defensive engineering gets extreme. Dependencygraph.json seems pretty straightforward.
Yeah, it shows the literal Python module imports. It informs the AI that the API listener requires JSON, OS, subprocess, and threading.
It's the literal bill of materials for the script.
It is. But runtimemap.json is where we see temporal understanding injected into the AI. It explicitly defines the sequential flows.
Temporal understanding, like time.
Exactly. For example, it maps the Vault processing flow step by step. First, scan the active intake data. Second, parse the metadata. Third, write the payload to the Vault JSON. Fourth, sync the state back to the UI portals.
So it gives the AI a sequential understanding of time, so it won't suggest a script that attempts to sync the UI before the metadata is actually parsed.
You got it.
Now, fieldmap.json is where I started laughing, because you can actually see Bruce's paranoia, and I mean that as a high compliment.
It's a healthy paranoia.
This file explicitly dictates read and write permissions at the granular variable level.
Wow.
Yeah. It maps variables like file name or videoid and tells the AI, listen very carefully. Only the Vault generator and Vault ingester scripts are allowed to write or modify the file name variable. Every other script in this entire system only has read access.
Which is a brilliant safeguard. It prevents the AI from generating a helpful little code snippet that accidentally empowers a front-end visual portal to rename a core system file.
It is strict access control enforced purely through context injection.
And finally, in this execution mapping subsection, we have orchestrationmap.json and orchestrationedgegraph.json. These track the physical execution chain at the OS level.
So they map out that a specific batch file, MusicPortal is the root entry point that physically launches API, listener.py, and mediaserver.py.
Exactly.
But why go to the trouble of mapping a basic batch file? If the AI is writing Python, why does it need to know how the Windows command prompt launches the system?
Because of the flash model behavior we discussed earlier.
Right.
If the AI is unaware of how the system physically boots up and it's trying to optimize initialization, it might suggest replacing that batch file with a completely different async Python boot sequence.
Which might be syntactically clever, but completely break the timing required by the external media players.
Exactly. By feeding it the orchestration map, Bruce is handing the AI a do-not-touch list for the core control flows. It forces the AI to respect the hard-coded reality of the operating system environment.
Wow. Okay, now we reach subsection C of the memory brain, the danger zones. And this, to me, is the absolute peak of this documentation.
The dangers are fascinating.
The files are AP causality registry enhanced.json, blastradius.json, and impactpropagation.json. Through these files, Bruce managed to give a language model something it fundamentally lacks.
A numerical understanding of consequence?
Yes, he mathematically quantified the cost of failure. Let's look closely at AP causality registry enhanced.json. This file catalogs the actual API endpoints and assigns them a literal numerical blastradius score.
It's incredible.
I have the data right in front of me. Look at the endpoint labeled /nuke system. Obviously, the name implies danger.
Yeah, that sounds bad.
But the registry explicitly tells the AI this endpoint has a criticality level of critical and a mathematical blast radius score of 51. It notes that invoking or modifying this impacts critical system action and state dependency.
Now compare that to a slightly less fatal, but still dangerous endpoint, /revert track.
Okay, what's the score on that?
This endpoint has a blast radius score of 25. The JSON details that it reads the vault, writes to the vault, and crucially, it triggers a target mapped as destructive file system because its function physically deletes the file from the intake path.
So the AI is explicitly warned of data loss risk.
Exactly. And on the complete opposite end of the spectrum, you have a simple /kill MPV command with a score of 3 or a /heartbeat ping with a score of 1. They are completely low risk.
So the AI is being explicitly trained. If you mess with the /heartbeat code, the worst that happens is a UI lag. If you mess with the logic for /nuke system or /revert track, you're going to permanently destroy the user's sovereign data.
And he takes it even deeper with blastradius.json and impactpropagation.json. These files score the potential of every individual script to cascade failure through the broader system.
Give me an example.
For instance, the API listener.py has a direct impact score of 3.0. But then you analyze notebook structure tools.bat within the impact propagation file, and it reveals a path count of 13.
Meaning, a failure in that single batch file propagates through 13 distinct layers of the local ecosystem.
Exactly. So by meticulously mapping the blast radius, Bruce entirely solved his heartburn problem.
The AI now possesses a mathematical understanding that modifying the curation studio is a high blast radius event.
Right. It won't flippantly suggest refactoring the ingestion loop for efficiency because it can literally calculate that doing so touches the destructive file system target and risks a cascading failure across 13 paths.
It's an incredible achievement. He successfully translated the human anxiety of system stability into a quantitative JSON schema that a language model can natively parse, respect, and operate within.
It's just a masterclass in AI collaboration.
So let's take stock. We have an ironclad, sovereign physical architecture running on a tri-drive empire.
Check.
We have a workflow that utilizes zero friction signals to deterministically rebuild itself.
Check.
And we have a JSON memory brain that perfectly maps the blast radius of the system so AI can safely assist in developing it without trampling sacred state boundaries.
It's locked down.
Now that the core system is safely locked down and fundamentally unbreakable, what's the next frontier? Where does a sovereign jukebox go from here?
Well, the documentation outlines Bruce's grand design mandates moving into the future phases of development. The primary mandate moving forward is the bulk harvest.
The bulk harvest. Sounds intense. He's trying to transition away from manual data entry completely, moving to zero typo automation.
Precisely. Currently, the system relies on an artist registry, but Bruce notes a severe fragility. A single extra space or an accidental lowercase letter typed into the UI creates a split artist bug, fracturing the database.
He needs to harvest metadata flawlessly, without human error.
But while database integrity is critical, the truly mind-bending evolutions in the grand design are visual and acoustic.
Yes, let's talk about the visual synthesizer. Because this system operates on that massive 70-inch display, it has to look like a high-end theater experience, not an Excel spreadsheet.
Right.
Bruce outlines plans to integrate an API called Nano Banana 2.
And the fallback logic he designed here is fascinating. If the local alert field for a specific band is missing in the vault, instead of resorting to a blank screen or a generic, boring music icon, the system dynamically reaches out to the Nano Banana 2 API.
And what does it do?
It generates a stylized, cartoonish fan art version of the band on the fly, based purely on parsing the text of the artist field.
That is so cool. And he takes it a step further with motion.
Yeah.
He's researching a tool called VO to actively animate live YouTube frames in real time.
Yeah, so if he's streaming a rare, low-quality 480p concert footage video, he wants to dynamically mask it behind high-fidelity, real-time AI animated art.
The system is proactively upgrading its own visual presentation to match the scale of the 70-inch screen.
But the true holy grail for data handling and the absolute final frontier of this sovereign architecture is what he calls audio fingerprinting, or the smart radar.
I'm looking at this audio fingerprinting section, and I'm honestly trying to wrap my head around it. If it's not looking at the ID3 tags written into the MP3, and it's not just listening for the lyrics like old school Shazam used to do, what exactly is it measuring? The literal file size, the byte trait.
It actually operates entirely on pure mathematics, specifically leveraging fast Fourier transforms to analyze the sound wave itself.
Okay, Fourier transforms, that sounds complicated.
It is. But basically, instead of relying on a fragile file name like track01.mp3 or relying on ID3 tags, which are easily stripped out or corrupted by different media players,
Yeah.
audio fingerprinting converts the raw audio signal into a unique mathematical map called a spectrogram.
So it's visually mapping the sound.
Yes. It maps the relative energy peaks of the audio frequencies over time. It identifies the loudest moments in specific frequency bands, maps them as a constellation of points, and then hashes that map into a highly compressed string of alphanumeric characters. What makes this technology the holy grail for an archivist is its resilience. Even if the local audio file is played slightly faster or slightly slower or heavily compressed down to a lower quality byte rate, those relative energy peaks remain mathematically identical.
So the fingerprint remains completely recognizable when queried against a global database.
Exactly. It is entirely immune to metadata stripping. It's the literal, unalterable DNA of the song.
And the sources mentioned he is exploring 3 specific tools to implement this. He's looking at AcoustID, which is the massive open source champion that powers the MusicBrainz database.
Yep, a very solid choice.
He's analyzing ACR Cloud, which is described as the enterprise heavyweight capable of identifying a song playing in the background of a noisy live concert video.
That's the heavy lifter.
And most interestingly for his off-grid philosophy, he's looking at Dejavu, which is a Python library that processes fingerprints locally for true sovereignty without needing to ping an external cloud API.
By successfully transitioning to acoustic fingerprinting, the MusicPortal ecosystem evolves dramatically. It transitions from being a passive file library into what the AI elegantly called a multi-source identity resolution graph.
That phrase is incredible, a multi-source identity resolution graph. It moves the system from guessing what a file might be based on the string of text somebody typed into the file name to knowing its exact digital identity with mathematical certainty.
It provides the ultimate unbreakable primary key for a data architect.
And think about how that completely changes the user experience. The system can now actively observe your habits and independently say, hey, I see you really like the acoustic fingerprint of this specific track. I scanned your massive, unorganized intake folders and mathematically identified the live version from Tokyo and a rare acoustic remix. Do you want me to pull those into the active queue?
It shifts the paradigm from just passively receiving and storing your data to actively identifying, resolving, and curating it based purely on acoustic DNA.
It creates a perfectly closed-loop ecosystem of absolute ownership, deterministic rebuildability, and infinite precise curation.
It is simply a staggering technical achievement for a single developer working on what he thought was a weekend pet project.
To quickly summarize this incredible journey, we started looking at what appeared to be a very simple user interface, just a little dark mode web portal.
Right.
And beneath the surface, we discovered a fully orchestrated, wildly resilient media operating system. It features a localized Python ingestion engine, dictatorial hard state synchronization logic, a Git-inspired deterministic rebuild protocol.
And a literal JSON-mapped memory brain engineered specifically to keep AI assistants from destroying its sacred state boundaries.
The sheer ingenuity of treating a personal, nostalgic media collection like a rugged, enterprise-grade infrastructure as code deployment is just remarkable.
He solved a massive, complex data problem by refusing to compromise on absolute sovereignty.
So we circle back to you, the listener. How much of the digital media in your life do you actually own versus just rent from an algorithm?
When you really audit your digital life, are you looking at a clean, stable structure? Or are you looking at a highly precarious stack of rented permissions that could disappear tomorrow?
It's an uncomfortable question for most of us to confront when we realize how little we actually possess.
It really is.
And I want to leave you with a final provocative thought to mull over. If one person, one dedicated paranoid architect, can build a completely sovereign, self-healing, incredibly intelligent digital empire in their living room, just to escape the friction of algorithmic curation.
Yeah.
What happens to the massive multi-billion-dollar streaming platforms when tools like this become widely accessible and easy to deploy? Are we looking at the beginning of a future where millions of people abandon the cloud entirely, taking back their data and retreating into their own highly intelligent, locally hosted, completely unbreakable walled gardens?
The architecture to do it is already here, sitting on a tri-drive empire.
It really makes you wonder if that diagnostic X-ray machine isn't broken at all.
Yeah.
Maybe it's just showing us a completely different, infinitely more resilient kind of skeleton.